Hello everyone and welcome to this video, which is an overview of the DOTS implementation or data-oriented technology stack in Unity, the implementation of the classic game Pong. This project is using Unity 2019.3.0 F1 and the latest entities and the new syntax and stuff like that. Now, before I get started, it might be worth talking a little bit about Pong as a use case for the data-oriented technology stack. Pong is a very simple game. It is really kind of overkill to try to make a DOTS implementation of it, but it was sort of a fun project, and really it just kind of shows some of the syntax and some of the cool things we could do, and to learn some of the new syntax. So it's just a very simple thing, and I was making this anyway, so I figured I'd turn this into a project and make the video about it. Now, here in my project, it looks 2D, however, this is actually just 3D objects. And I did 3D instead of 2D because I wanted to utilize the new Unity physics, which is the DOTS physics implementation. And so by having 3D objects, it just makes it simpler. I can just throw colliders and stuff on there and we're off to the races. Now, if I go up to my package manager here, we can take a look at what's currently enabled. The things that I absolutely need is I need entities, right? And you can see the version I'm using here. That's going to give me like burst and mathematics and jobs and all that stuff. I need the hybrid renderer, or else the entities I create will not be rendered, won't be visible. And I am using Unity physics or DOTS physics or whatever here in my project. All right, so some things I already have in here. So I've got some walls, again, 3D objects. I have some paddles that we're going to be using to move around. I have a ball, which is just a sphere. And I have this game manager game object, which has this class on it, this mono behavior, that's just going to store some of my universal or global, variables and settings and stuff like that. You can see I've got an array for the player's scores and some UI stuff here. And and that's all kind of set up already. And if I look at the game view, I just sort of see this. I've put an unlit shader on everything. And so it just kind of looks like this. And this is the framework by which we're going to go ahead and get started. Now, I'm going to go ahead and open my game manager and just take a look at some of the code that's already written. I'll be writing the rest of the code, but since this isn't DOTS specific, I just already had this written out. And so this game manager is a sort of singleton design, and I know people have mixed feelings about that, but that's the way I like to do stuff. And I'm going to have a public game object prefab here, some variables to define my left and right X bound and Y bound, how fast does the ball go, how long do we wait to respawn once someone scores a point. And then we have we have the player scores. And I made this an array instead of just doing like player 1, player 2, because maybe in the future we'll add more than one player or whatever. So I just made it so it's fairly simple there. And the same for our UI text for the scores of the players. I have some variables here, an entity and an entity manager. We'll talk about this once they become relevant. And then I just predefined some delays. This script is going to use a coroutine, and so instead of saying like a new wait for seconds each time, which allocates memory, I'm just going to define these ahead of time. Here inside my awake is the whole singleton pattern. I'm going to say, hey, if there already is another game manager in existence, then just go ahead and delete this one. Otherwise, this becomes the main game manager. We initialize our player score array. We declare and initialize our delays for our countdown. And then we start this coroutine countdown and spawn ball. I also have a public method here that's going to be called whenever the ball score ends up in a goal. That's going to update whatever player's score and then update the UI. And again, countdown and spawn a ball. Inside this coroutine, we're basically just going to count down, get ready, 3, 2, 1, and then we spawn ball. And right now, nothing is in here yet. We'll write that code later. All right, so game manager is pretty straightforward. Nothing too spectacular there. Mostly just wanted to have that code already written. All right, so let's go back to our project here. The first thing I'm going to do is the easiest. I'm going to go ahead and take my upper and lower walls, and I'm going to turn these into entities so that they can work with physics. Now, I don't need to add physics stuff here. As a matter of fact, DOTS physics stuff here. I don't need to add like a physics shape and physics body stuff. Actually, what's going to happen is those will be added automatically because I have a box collider here and a rigid body here. So when I convert these to entities, they will automatically be converted to the DOTS equivalent for me. One thing I am going to do here, I am going to go ahead and just drop a bouncy physics material on here because we're going to be using the built-in physics. I'm going to want the ball to bounce around. I'm going to have the same on my paddle, so I just want to have that here. And then what I'm going to do is I'm just going to go to add component, dots, and then convert to entity. And now these walls will be converted to entities automatically when I run this. So if I were to say hit play, and the first time once we create some new entities and stuff, it can take a couple seconds there. I hit play and my lower or my upper wall is gone. My lower wall's still here, but my upper one has been converted to an entity. If I go to my entity debugger, which I can open by going to Window, Analysis, Entity Debugger, I can see there is my upper wall. There you go. It's been converted for me, and it has all the physics stuff automatically. So I'm going to go back to my upper wall here, which has this convert to entity, and since it's a prefab, I'm just going to apply that. So my lower wall has it as well. Now for paddles. Paddles are going to need a couple things. So first off, they have their box collider, bounce material, rigid body. I am going to add a convert to entity on there, so they'll be converted to entities as well. But now we need to move them. We need to control them. There's gameplay involved. And so I need to create a few things. So first off, my paddles need to move, which means I need to read input from the player. My paddles need to define what input they care about, right? So I need some data to say, hey, which keys on the keyboard am I looking for? Furthermore, I need a system to move my paddles, and I need some data to define, okay, well, based on my input, how am I moving? What am I doing? What are the results of this, right? So just a few things there. So let's go ahead and write this code. So in my scripts folder, I have a data components folder, and I've got some scripts in here. These are all empty right now. I just created them so you don't have to watch me create those. And so the first thing I'm going to do is I'm going to go to my paddle input data. So this is going to be the data that defines what keystrokes each paddle cares about, right? Or you could think of a paddle as a player or whatever. So the way I want to set this up is this is going to be very simple. Two players are going to play using the same keyboard. So let's say the W and S key moves my left-hand player and the up and down arrows move my right-hand player, keeping it very simple here, right? So just a basic game of Pong. So I'm going to create a data struct that's going to store that configuration information that I care about. So, and I do apologize. I have a very loud keyboard. So if you're wearing headphones or whatever, you may want to turn it down. But, you know, I'm using a mechanical keyboard. I always like my code to be strongly typed, so I use a very loud keyboard. So I'm going to say public struct. Then I'm going to say paddle input data. This is the data I care about, and this is going to be a type iComponent data. There we go. If you're curious how I have iComponent data, it's because I'm using Unity entities up top here. And so what do I care about here? Well, I'm going to care about two key codes. So I'm going to say public key code, and I'm going to have an up key, and then I'm going to have a public key code, framed it for me automatically, down key. There we go. Now, how do I use this? So I could create an authoring script. Basically, it's a monitor behavior that's gonna, at runtime or whatever, say, oh, this is being converted. Let me, through code, add these components and configuration data or whatever. Or I could have Unity generate one for me. So I'm gonna use this new attribute. This is some new syntax, generate authoring component. And now back in Unity, if I click on my paddle once this compiles, right there, I'm going to go ahead and just drag this paddle input data on here, and we can see, all right, these are our keys. Okay, and I'll fill these out in a second here. The next thing is, all right, so this is the input data, but once we read the input, we need to give this paddle some data that's going to define how it moves. What does that input translate to? So I'm going to come here to this paddle move data, and I'm going to do the same here. So I'm just going to go ahead and create a public struct that I'm going to call paddle movement data, like that, and it's going to be an iComponent data. And I'm going to say public int direction. I don't know why that didn't indent. There we go. So am I going up or am I going down? What direction is this paddle moving? I'm also going to say public float speed. How fast does my paddle move? All right, this by having it like this instead of just sort of some universal property, paddles can move at different speeds if you ever wanted to like add power-ups or whatever. So it just gives us a little bit of freedom there. And again, I'm going to generate an authoring component for me here. All right, so I'm going to come back to Unity, and now that we've defined those two pieces of data, I'm going to go back to my paddle, and I am just going to drag my paddle movement data on here. Oops, this looks like I missed. There we go, just drag it down there, that works. So direction will be 0 to start with. Speed will be 4. I like how it automatically creates these fields and everything in the authoring component. So my paddles move at speed of 4 to start with. So this is my paddle 0, my left-hand player. So I'm going to say that they are going to move with the W and S keys. So I just sort of have to click this down arrow as these scroll past. So there's W, and then for my down key, I go to S. There's probably a faster way to do this, but whatever. There it is. Okay, cool. Now, since these are prefab, I'm just going to go ahead and apply those changes. And now on paddle 1, I have all these, but paddle 1 is not going to be looking for W and S. Paddle 1 is going to be using the up arrow and the down arrow. Awesome. Now, if I hit play, these paddles will be converted to entities, but they're not going to move. Nothing's going to happen, all right, because I have not yet defined any logic to my data. It's just data at this point, and I need systems to do something with that data. So what do I need? Well, I need two systems. One system is going to read my inputs and convert that to some movement information, and then another system is actually going to move them. So I'm going to go over here to my code, to my systems, and I have this player input system. I'm going to open this up here, and here is where I'm going to specify what do we do with this. So I'm going to start by saying public class, and I'm going to say player input system. All right, and this is going to be a type job component system. Now, if you're familiar with writing any dots code, you might be familiar with component systems versus job component systems and how you might write either of those. So with the new syntax, it's kind of been simplified. So now, whether or not you're using worker threads or you're writing code for the main thread or whatever, you could just say job component system. You no longer have to say, component system for main thread and job component system for worker threads, whatever. So it's just sort of been simplified there. And I'm going to right click and I'm just going to say, hey, you know what? Implement this abstract class for me, which is going to give me my on update code here. And I don't want to throw an exception there. So I'm going to delete that. And so now what I'm going to say is I'm going to say entities, all right, dot for each. This used to be component system only syntax, but now we can use that with job component systems for single thread or multi-threaded. And I'll show you here how momentarily. And so I'm going to say for each. And now inside these parentheses, we need to create a lambda expression. So basically what that means is in between these parentheses, we are going to have a list of, a list of parameters inside some parentheses, and then an equal sign, and then an arrow like this, and then we're going to define some method. All right, that's ultimately this, sort of syntax. Now I like to write that like this, so I'll generally write my code that looks like this. That's just how I like to look at it there. So I put my parameters in here and then what I do with those parameters inside here. So what parameters do I need? Well, I need a paddle movement data, which I'm going to call move data, and I need paddle input data, all right, which I'm going to call input data. There we go. And then I'm going to do something here. Now, this in and of itself isn't quite right, because I need to tell the system, am I manipulating this data or am I only reading this data, right? And which is important, because if Unity is trying to schedule other jobs and trying to line up the correct order to do things, it needs to know if you're not going to be writing to some data, you're only going to read it so that it can allow multiple things to access it at the same time. That's all reading it or whatever, right? So that you can make more efficient code. So move data we're going to write to. Right, so this player input system is going to read from our input data and write to our move data, but it's not going to write to input data. So since we're writing to move data, I'm going to say reference, paddle movement, move data. Since I only need read-only access to my paddle input data, I'm going to say in. So there you go, ref for writing to, in for reading from. Also, all of our ref variables need to come first in our list, and then our in variables come second, right? So I couldn't do like in and then ref. I have to have all my refs and then all my ins. There we go. So inside here, what am I doing? So I'm going to say move data dot direction equals 0. Basically just clear out any remaining direction. And then I want it to be a positive 1 if I'm going up and a negative 1 if I'm going down. So I'll say move data dot direction helps if I spell it right, plus equals, and then I'm going to say input dot get key, and I'm basically going to do a condensed if statement, a ternary operator, I believe it's called, not tertiary, that means 3, ternary. So I'm going to say input data dot up key, and then I'm going to say question mark. So am I pressing this key? Question. If I am, then I'm going to add a value of 1. If I'm not, I'm going to add a value of 0, right? So if I'm not pressing the up key, my direction will remain 0, and if I am, my direction will become 1. And I'm just going to copy this line, I'm going to paste it. For moving down, I'm going to say minus equals input data dot down key. There we go. So am I pressing the down key? If I am, a value of 1, otherwise a value of 0. There we go. So that's all we really need to do there. Now this needs us to return a job handle. So I'm just going to say return input dependencies. Right? So we're just going to sort of pass it through. Now, one, I want to make it clear that this syntax works. It's not the greatest syntax, and I'll talk about why. And two, this isn't actually going to run yet because of the way the syntax has changed. This used to be enough, and that was that. So this is kind of a gotcha right now with the new syntax. So saying entities.for each, just like this, isn't quite going to work. We need to tell it, do we want this to run on the main thread, or do we want to schedule this with our job system to run on worker threads? So if we want to schedule it, if we want it to run like multi-threaded on worker threads, we would say dot schedule, and we'd pass in maybe our input dependencies. However, this needs main thread stuff. This is accessing the input class. So it needs to be on the main thread because it's accessing things that exist outside of our worker threads. So I'm going to instead say .run. And .run is going to say, okay, run this on the main thread. Now, since this is running on the main thread, the way I'm handling my reading in job input dependencies and returning job input dependencies isn't quite right, because the next system in the chain is going to say, what happened in the previous chain? Am I waiting for anything? Is there any asynchronous work that needs to be wrapped up before it's my turn? And so, it's going to have some delays while it's doing some safety checks, some thread safety checks and stuff like that. So we can simplify this a bit. I could say, for instance, here at the top, input dependencies dot complete. And then I could say, return a new job handle. Right? So wrap up everything this one's doing and return a new one and let things continue on. That's one way I could do it. Another way I could do it is, and maybe a better way yet, is to use the new attribute, which is always synchronize system, and then I could return back input dependencies like this. However, maybe the best way to do it, I think the best way to do it, so that it's completely clear what you're doing, is to utilize our always synchronized system and leave just input dependencies alone and just return back default. There we go. All right, so basically we're not using input dependencies for anything. We're just returning back some default here, and we are always synchronizing our system because it's main thread, and so we are going to finish up any main thread work that has to happen before this one, then we're going to do this one, and then the next system can do its thing, and so the Unity scheduler can optimize this. So that is the way I'm writing this code. If that doesn't make a lot of sense, just check out the documentation or whatever. Basically, this is kind of new ways that we can look at the stuff to maybe handle it a little bit faster. All right, so that's my input system. So that's going to read in my inputs and write to my data. Now, how do we actually move these paddles? So I'll come back to Unity here, and I have a paddle movement system, which I'm waiting for this code to compile. There we go, code compiled. And now I'll open this up, and our paddle movement system is now going to take that input data and do something with it. All right, and again, we're going to look at some of this new syntax and some gotchas and things like that. So I'm going to say public class paddle movement system, just like that. And this one is going to be a job component system, again, like that. And I am going to implement the abstract class. There we go. And what I'm going to say, so first off, I need some stuff that's going to make my calculations work smoothly. So first off, I'm going to declare a variable float delta time, and that's going to equal time.delta time. There we go. And I'm also going to say float Y bound. So what's our upper lower Y bounds? Because we're going to clamp the paddle's position, and that is going to be equal to our game manager dot main dot Y bound. There we go. So we'll just have that data. And next we are going to schedule a job here. We're going to schedule entities for each. This time, for now anyway, I'm going to schedule this on multi-threads, on worker threads. Now I'm not going to keep it that way, but we're going to start that way, just so you can see the syntax. So I'm going to say job handle, and I'll say maybe my job, equals, and this time now I'm going to say entities.forEach. So I'm assigning the result of this entities for each to a job handle. And so inside entities for each, again, we have the syntax like so, just like this. Now it's going to freak out for a moment. Because it's going to say, well, down here it's going to be thinking, hey, this doesn't return a job handle. I'll get to that in a moment. So what variables do I care about? So first off, I care about translation, which is just our new way of kind of saying the position, right? So translation, how we're moving left and right, up and down, whatever. And my in paddle movement data, which I'm just going to call data, right? Because it's in, we're not writing to it now, we're just reading from it. And we are going to now write to our translation. Now inside here, I'm going to go ahead and say translation, so dot value, the value of my translation, dot y. All right, so what is our y's position? And so we're going to add this, basically movement speed and direction and delta time to our current y value, and then we're also going to clamp it. So I'm going to say math.clamp, all right, and inside clamp, which I'm going to write like that. Inside clamp, I'm going to say, all right, well, our current value, y value of the translation, plus data.movement speed, oh, it's just speed, data.speed times data.direction, are we going up, are we going down, times delta time, there we go. So that's going to be the value, and then I'm going to say, okay, well, what's our lower bound, negative y bound, and our upper bound is positive y bound. So that's just going to clamp it for us. So clamping the results of this here. Now this whole thing is still freaking out, right? Because it's saying, hey, this is asking for a job handle. None of this creates a job handle. So I need to schedule this, right? So I'm going to do, like I said with the other one, I'm going to schedule this, and it's relying on these input dependencies. And then at the end of this, I can just say return my job. There we go. And this is the way in which I can create a job component system that has a system query and then some execution that is then scheduled to run on a bunch of worker threads and things like that. Now, all of that being said, I'm not going to keep my code like this. The reason for that is that this system is very, very simple. It is simply moving a paddle or moving something up and down and clamping its bounds. Furthermore, there are only 2 paddles. So this is going to take basically a negligible amount of time, an infinitesimal amount of time. As a matter of fact, the amount of time it takes to schedule this job and run it on a worker thread is greater than the amount of time it takes to actually just do the work. Now, that being said, scheduling jobs and stuff like that doesn't take that long. It's a fairly, very efficient process, but that's how simple this system is. It basically does nothing, right? So as such, it's less efficient to run this on worker threads than it is to just run it on the main thread. So that's what I'm going to do. So here I showed you this just so you could see the syntax of it, but it's just more efficient just to run this, just to say run, and return back default, and up here to do our always synchronize. It's just faster that way. So that's what we're going to do. So now, again, we're just running it on the main thread because it's a very simple, very fast thing to do. Now we're going to come back to Unity. I'm going to let this all compile. I will make sure my paddles has the data it needs. It does. And I'm going to hit play. Now the ball's not going to move or anything like that. We are going to see this countdown because that's just sort of built into the game manager there. But more importantly, I can see that W and S moves my left paddle that is clamped. Up and down moves my right paddle, which is also clamped. There we go. So paddle movement is done. Fantastic. All right. So now it's time to move on to the ball. Now with our ball here, we want to just add again some physics stuff. This will eventually be turned into a prefab, which will be spawned by the game manager and stuff like that as an entity, but I just have it in my scene to start with. And so the first thing I need to do is I'm going to set up the physics on my ball. Now I could go back to my 3D physics, my NVIDIA PhysX, built-in physics, and do like a sphere collider and a rigid body and whatever, but I'm actually going to do the dots way of doing this. So I'm going to go to the dots physics, and I'm going to add a physics body, which is like a rigid body. And it's going to say, hey, you're adding a physics body, but this isn't being converted. So, you know, it's not going to do anything. Good luck. I'll fix that in a second. But I'm going to come down here. This is going to be a dynamic body. I don't want any drag or damping, linear or angular. For now, I'm going to give this an initial linear velocity. This will eventually will zero this out because we're going to use the spawner to do that. I don't need it to have any angular velocity. I'm going to say no to gravity to start with. And I don't need to override mass distribution or custom tags or anything like that. The next thing I'm going to do is I'm going to go ahead and add a physics shape, which is basically our collider. And this is going to be a sphere. And I'll just clear out, there's a slight decimal offset there for the float stuff. I'm just going to set those to 0. And I could add a physics material template here, or I can just add it, set it up myself. So I just want there to be 0 friction, and I'll set that up to minimum. And I want maximum restitution, super duper bouncy. There we go. And I could set up some collision filters like, you know, this belongs to a special ball layer that only collides with everything that's not on the ball layer or whatever. So that I could, maybe if I had more than one ball and I didn't want them to collide with each other or whatever. But I don't have that. I don't need that. So I'm going to leave that as it is. Now, to get rid of this error here, I am going to go ahead and add the convert to entity stuff right there. Cool. So at this point, if I hit play, that ball should move around and bounce around. There it goes. Cool. All right, so it's moving, it's bouncing with physics being converted to an entity. So the next thing I need to do is 2 things. So the ball, one, needs to detect, hey, has the ball reached the goal? So has a player scored? Let's let the game manager know about it. The other thing is the ball is going to speed up over time. Now, that is not a Pong mechanic, but basically, I was playing the game and realized that if 2 players are decently good at this game, the game can go forever, and that's kind of boring. So just making the ball speed up as the game goes on is, you know, in my mind, pretty fun. So I'm going to add some new components to do that. So the first thing is this ball tag component. I'm going to open this up here, and I'm just going to start by saying generate authoring component. This is going to be a public struct ball tag, which is an I component data. Now, I'm using this as a tag, which I like to just put the word tag on it so you know. And what I mean by that is there's no data in here. This does not store any data. I'm just going to use this in queries to say, hey, find me everything that has maybe, say, a translation and a velocity and is also a ball. Right? So, you know, I don't need to have any data in here. This is purely for identification purposes. So the next one I'm going to write to is going to be my speed increase over time data. So I'll just pop this open here. And again, I'm going to say generate authoring component. And this is going to be public struct speed increase. I could have picked a shorter name over time data, also an I component data. There we go. And inside here, basically I need one thing. So I just need a public float. Now, speaking of standards, right? It's pretty normal that if you have a I component data with a single thing in it, you name it value. And we saw this with the paddle movement system where we have translation dot value, and that's pretty common. Doing value is normal, but in my opinion, if what your value is not particularly clear, then give it a name. So for instance, if I do speed increase over time data dot value, what is that value? Is that the maximum speed, speed per interval? What's the interval? What does that mean? And so what I'm going to say is increase per second is what I'm going to name this. So that it's very obvious. This is the speed increase per second. Cool. So that's how I'm going to do this. Now that I have that and I have the ball tag, I can create my system that's going to speed the ball up. And so I'm going to let this compile. And then this is going to be my increase velocity over time system. And I know a lot of people might be like, oh, well, is it velocity or is it speed? Because one's scalar and one's vector, whatever. Basically, we're speeding stuff up and get over it. So here is my increased velocity over time system, and I'm going to make this a job component system, just like this. And I'm going to allow the IDE to implement that for me so I don't have to type. There we go. And I'm going to say, again, float delta time equals time.delta time, just so I want to have those things available to me. And then I'm going to say entities dot for each. Here we go, for each, and I will set up my expression like so. And inside here, the data that I'm going to be looking at. So first off, I'm going to reference my physics velocity. There we go, which I'll just call VEL. Because I'm going to be modifying this one. And then I'm going to say in speed increase over time data, which I'll call data. And that's in because I'm not going to be modifying. I'm just going to be reading from it. So inside here, I needed to calculate what my value is, or my modifier is. So I am going to say float2, which I'll call modifier, equals new float2. And inside here, I'm going to say data.increase per second times delta time, just like so. All right, and so we're going to have, oh, I spelled modifier wrong. There we go. No one warned me. And then I'm going to say, all right, so that's going to be my modifier for, this particular interval. And so I'll say float2 new velocity is going to equal velocity dot linear. That's the linear velocity dot xy. We don't need the z. So basically, all right, so what is our current velocity? Grab the linear, not the angular velocity or its rotation. It's linear velocity in the xy. We're going to grab that here. And then we're simply going to say new velocity plus equals, all right, math.lerp, everyone's favorite, linear interpolation, lerp. And I'm going to lerp between negative modifier and positive modifier based on math.sine, the sine function, new velocity. All right, so this is basically going to increase our speed, all right, or give us basically this new velocity. Then I'm going to say velocity.linear.xy equals new velocity. So I'll just write it back. So basically we're grabbing a velocity, we're modulating it by this increase per second, and then we are setting that back there. Now this is going to be main thread, right? Because for very much the same reasons of there's one ball, there's really no point in running this on worker threads. It's very fast, so I'm just gonna say run, like so. And then I'm just going to say return default. And since I'm returning default, I'm going to go ahead and do my always synchronize systems like so. All right. Now, if you're not familiar, if you're looking at this code and saying like, what is happening here? Math.sine, we're basically going to say like, okay, well, if we're moving to the left, right, or downward or whatever, then we're going to be using this negative modifier to move us leftward. If we're moving to the right, positive modifier, so we're above 0, we're going to be using the positive modifier. So just in case you're looking at that and being like, what's happening here? If we're going left or down, we're using negative. If we're going right or up, we're using positive. And that way we're not damping our speed, we're increasing it in whichever way we're going. Cool. Another thing you might be thinking at this point, I know it's maybe just kind of tangential, is why did we have two different systems for our input and our movement? Because they could be the same system. And I meant to bring this up earlier, and it's just now like popping back into my mind. And the way these are currently set up, you're absolutely right. Since these are both on the main thread, one is reading in our inputs and setting some data for movement, and the next is then just moving. You could realistically just make these one system. The reason I have them as two systems is a couple things. You might have inputs for things that necessarily maybe aren't paddles, even though this is specifically saying paddle input and paddle movement, right? We may have one input system that reads our input and sets a bunch of different data on a bunch of different entities, and then a movement system that handles movement for a bunch of different things. So coupling those two things together doesn't make a lot of sense logically. It's better just to keep those separate. But the second reason really is that player input system has to be on the main thread because it's using input.getKey, and our paddle movement system doesn't have to be on the main thread. As a matter of fact, if I had more paddles or if this was doing more work, I would run this on worker threads. So it makes sense just to keep these separate. They're not doing the same thing anyway. And later, if I add more stuff, I can just make this, run multi-threaded by just scheduling it instead of running it. So in case you were looking at this and thinking to yourself, why have two systems for this when they're, so very simple and they can so very easily be combined? You're absolutely correct. But I wrote it that way because, that way we have some flexibility there. All right. So I know that was a bit of a tangent there, but coming back to our increased velocity over time system, this is all written out now. And so our ball will speed up over time. And if I come back to Unity and I let this compile and we hit play, that's exactly what we should see. So let's see this compile here. Actually, scratch that. It occurs to me that we never actually put that data on the ball. So I'm going to go to my data components here and I'm going to add the ball tag. There we go. And the speed increase over time. And let's give it a speed increase of, say, 0.2. And so what we're going to see here is that's going to add a little bit of randomness to our movement and some speed increase. So it's going to make it a little bit harder to play. So now it's kind of bouncing down like that. And so now the ball is going to move a little bit less predictably. Originally in Pong, you could do like corner shots and stuff like that, which would make it speed up and kind of angle a little bit harder. I don't have any mechanics like that, but this sort of is going to simulate something similar to that. Okay. So now that I have that, the last little bit here is I need to determine when, the ball has made it to the goal and is going to score. And so I'm going to go here and I am going to go to my systems and I'm going to go to the ball goal check system and I'm going to go ahead and create this. So this is going to be a job component system. Nope, not job chunk extension. Job component system. There we go. I'm going to let this write out for me there. There we go. And so we're going to have a slightly different syntax here. And so I am going to say entities dots, and of course I'll be doing for each. And I will write out my expression like so. At this point, we've seen it a few times. All right. And I'm not just going to do for each. I also want to make sure that I'm checking out that ball tag, but let me explain why here. So the query, the actual data that I am checking is, first off, I want the entity itself as part of my query because I may need to destroy it. If the ball makes it to the goal, I want the ball to go away. So I'm going to need the entity to do that. I'm also going to read in its translation. All right, which I'll just call trans there. So if my query is anything that's an entity with translation, I'm going to be running this system on everything, every entity I have, which doesn't make a lot of sense because I'm only looking for the ball. I could try to put the ball tag in my query here, but that doesn't make sense. There's no data. There's nothing to actually query. So I'm going to get an error if I try that. So instead, I'm going to do this. I'm going to layer this, and I like to just put each of these dots on a new line. So I'm going to do entities with all. All right, and inside here, I'm going to say ball tag dot for each. So now it's saying, okay, entities, all entities that have ball tag, here's the query to run against, right? So only get things that are entities with translation that is also containing ball tag. Furthermore, I can keep going. There's a lot of stuff we can do here. We can say like with structural changes, which I'm going to talk about here in a moment. So I'll leave this here now. I'm not actually going to leave this in here permanently because I'm going to show you a better way, but we'll just leave it in there for now. I could also say with burst to say enable burst compilation, right? Now this is a bit of a misnomer actually. So normally you would use the attribute to say burst compile or whatever. This is burst, I want burst, whatever. With the new syntax, what you'll notice if you it's not doing it now, but you'll get a notification here that with burst is being deprecated. Instead, burst is just going to be turned on all the time, and it would be up to you to say without burst on the things that you don't want burst, right? I'm just going to leave this here because I just want it to use the burst and stuff like that. And so I have it like that, and that's good. So entities with all, ball tag with structural changes for each with our entity query here. All right, so there's all that. What are we actually doing with this? Well, I'm going to say float3 position equals translation.value. All right, so that's going to be the position of this entity. And then we'll say float bound. So what's our boundary? It's going to equal game manager dot main dot xbound. There we go. And so now what I'm going to do is I'm going to say, all right, so if my position dot x is greater than or equal to my bound. So if I'm all the way to the right, then what I'm going to do is I'm going to say, oh, there we go. Tabbing sometimes gets weird inside here. I'm going to say, hey, game manager dot main, the player has scored, and it would be player 0 that has scored in this situation. And then I'm going to say post update commands. Oh, nope, that's wrong. That's old syntax. My apologies. I'm going to say entity manager dot destroy entity, and I'm going to say, so destroy the ball. Okay, the player scored, and you know, we don't need this ball anymore. Otherwise, I'm going to say if position dot x is less than or equal to the negative x bound, or which in this case is just bound, then I'm going to say, all right, well, game manager. Again, main player scored. This time it was the right side player, player 1. And again, I'm going to say entity manager, dot destroy entity. And again, we're just destroying this entity. Cool. Now, you may be thinking, well, are we going to schedule this main thread or are we going to schedule this worker thread? Well, hopefully you can see that since we're using entity manager here, since we're referencing game manager, which is all on the main thread, that this needs to be, again, on the main thread. So I'm just going to run this, and I'm going to return default, and I'm going to come back to the top and say always synchronized system. So this game is actually going to use three main four main thread systems. We're not going to have any worker threads because nothing about this is complex enough to need it. And so there we go. Now this will work. And the reason I can use entity manager.destroy entity, anything with entity manager, is because I'm saying with structural changes. So I'm saying, hey, let's create a special version of this data that is going to allow me to modify it without invalidating the structure of data, which is traditionally causing errors in dots, right? So this allows me to bypass that. That being said, there's another way we can do this, and there's another way I'm going to do this. So with structural changes is simple enough for simple data. And if it was just me writing this Pong game for my own personal use or whatever, I would leave it like this because this Pong game is a very simple game. There's not a lot of data. The reason I'm going to change it is for you. You're welcome. I don't want you thinking that with structural changes is the way you go all the time. As a matter of fact, if you're creating a game that is more complex, much more complex, with structural changes can end up causing some slowdown because it's making a specialized copy of that data that you're going to be making structural changes against. And so I'm going to get rid of that. Sorry with structural changes. I liked you, but you're ultimately bad for me. And I don't want anyone here writing code and then later being like, but Mike said to do it this way and yelling at me on Twitter or anything like that. I don't need that drama in my life. So I'm going to do it this way. I'm going to say entity command buffer, good old entity command buffer, ECB, equals new entity command buffer with an allocator, which is temp job. There we go. So there's my entity command buffer. And I'm just going to write to this entity command buffer all the commands I want to do. And then after my my work here, I'm just going to play it back, right? Which is the other way we do this. So now I'm going to come down here to where I say entity manager.destroy entity. And I'm just going to say ECB, entity command buffer, destroy. So add this to our buffer of commands to do, ECB.destroy entity here. And then after run, I'm going to say, all right, now that we're done running, and now it's time to do something. So I'm saying, hey, let's play back our entity command buffer with our entity manager. So, hey, entity manager, do all these commands that we recorded Now, unspool and do all these things. And then once we're done with that, we can say, all right, well, now we're done with our entity command buffer. So there we go. So this is the way I'm going to do it, right? So entity command buffer, we're just going to use that, and then we're going to write it back. Instead of making structural changes to our data while we're working on it, which again, works very well in simple situations, but if you're not in a simple situation, can cause some slowdown. I didn't want you to think that's the way I was saying to do it all the time. So there's 2 ways to do it. You've got so many options. All right. And so now if I come back to Unity, I'm going to go ahead and just let this run. And we're going to see that the player is going to score. All right. Let's see what happens. Ball is going to come in. It's going to bounce. And there we go. We scored a point. The entity was destroyed. However, Game Manager hasn't been set up to spawn a new one or anything like that. We also have an interesting error. So if I go to my console, I see this. I see that this managed class type Game Manager is not supported. Loading from read-only static or non-read-only static field is not supported with burst. Right? So we have a burst error here. All right, so let's fix that. So I talked before about how we can disable burst for things that don't support it. So that's exactly what I'm going to do. Well, I can't reference Game Manager here like this, so I'm just going to say, all right, well, fine then. Let's not use burst, and let's move on with our lives. So I will let this compile, and then run it again here, and no error. Cool. Okay. Good stuff. And I didn't do the cheating thing where I just hide the error, so it's gone away. It's actually gone. Okay, so the last bit of this game, we're almost there, home stretch, is I would like to have my Game Manager spawn this ball for me. So I'm going to go ahead and turn this ball into a prefab, like so. I'm going to delete it from my scene. I'm going to go to my Game Manager where it says, what's my ball prefab? And I'm just going to drop that on there like so. And then I'm going to save my scene and open up my Game Manager again to write this code. So the first thing I need to do is up inside my awake method is I'm going to convert my entity or my ball prefab into an entity in awake so that it's just done. And I am also going to utilize this manager to do that and to spawn new ones, just like that. Now I am going to end up converting this game object to an entity here in the awake method. I could do that ahead of time in the editor using like the subscene workflow or whatever, and then just store it as an entity or whatever. But you know, for now, this is simple. This is straightforward. So I'm just going to do it this way. So what I'm going to do is first thing, and this syntax has changed a little bit. All right. So I'm going to say, hey, entity manager, right up here, this variable entity manager, manager. And I used to do like world.active entity or get entity manager or just entity manager or whatever. That syntax has changed a little bit. So it's going to be world.default game object or game object injection world dot entity manager. And that's a longer way of saying when we turn game objects into entities, give me the world those normally go into, right? Just what's our default world for doing that, and give me the entity manager of that world. Because that's not necessarily the active world. That's the one that we generally inject entities into. So give me that entity manager. Next, I need to create a game object conversion settings, which I'm going to call settings. And that is going to be game object conversion settings dot from world. So give me the settings from a world. Well, what world? Well, I'm glad you asked. World.default game object injection world. And then null for our second parameter there. All right. So there we go. It's a long-winded line there, but there we go. And then finally, I'm going to say, all right, well now I'm going to say, hey, ball entity prefab, you are going to equal game object conversion utility dot convert game object hierarchy. There we go. And I'm going to pass in the ball prefab, which is our game object prefab, and the settings we declare in the line above it. So take this game object, and in this world, you know, these settings, go ahead and convert it and store it here. Now, in newer versions of dots packages, like maybe the newest physics and animation, stuff like that, we can provide values here to do stuff like blobs for assets and things like that. That's kind of beyond this simple game, so I just left that as null. But you'll see that this syntax can grow, and there's more stuff we can do with this. But this is a simple conversion, right? So I have a ball that's a game object, give me a ball that's an entity. All right, pretty straightforward. So now the final little bit here, I'm going to go down to this spawn ball, and here I'm simply going to say entity ball. So give me a new ball is going to equal my manager, which is my entity manager, dot instantiate. So make one for me. Make me a copy of this ball entity prefab. Name ball. Cool. And then I want to give it some new velocity, right? Some new randomness to it every time it spawns. So I'm going to say vector3 direction equals new vector3. All right. And inside here, I'm going to say Unity engine. I need to specify random.range because now there's going to be some ambiguation between random that's part of Unity engine, random that's part of system. So I'm just going to type it all out like this. Random range between 0 and 2. All right. So I'm going to say, all right, pick a number that's either 0 or 1, because if I'm doing integers, it's exclusive. So it'll give me values of either 0 or 1, but never 2. And so I'm going to say, all right, did you give me a 0? Right? So basically, evens or odds, flip a coin. Did you give me a 0? If you did, then my first value here is going to be -1, so I'm going to be going left. All right? Otherwise, +1, going right. And then for my y, I'm going to be doing something like Unity engine dot random dot range. Now I am not doing the same here, where I'm going to go 0 to 2 for either left or right, because if I did -1 or +1, what effectively would happen is the ball would just go up and down, or left, and so it'd be doing major jumps at 45-degree angles, always 45-degree angles. And so the game would be fairly predictable because it's either going to go upper left, upper right, lower left, or lower right. So instead, I'm going to do random.range, and I'm just going to say -0.5f to 0.5f. And since they're floats, they're inclusive, so it'll give me numbers between -0.5 and +0.5. And that's it. There's no decision tree there, so we're just going to have some slight arc variance there on the y-axis, and then finally 0f on the z-axis. And I'm going to say normalized. Normalize that vector for me. There we go. That way they go the same speed no matter what. And then once I've done that, I'm going to say vector3 speed is going to be equal to my direction vector I just created times ball speed. There you go. So our direction vector times the speed of the ball. And now I'm going to say physics velocity. There we go. I'm going to declare a new physics velocity component, which I'm going to call velocity equals new physics velocity, like so. And inside here, I'm going to say, so my new linear speed is going to be equal to speed, and my new angular speed is going to be equal to float3.0. So you're not that one. So we're going to say you are not turning at all. And then I'll get my tabs right. That's not right. I hit the insert key on accident there. There we go. And finally, hey manager. So I want you to add a component for me. So let's add some component data here. And not chunk component data. Getting late into the video, and so I am having some typos. And it's going to say, well, what entity? Well, this ball, and I want you to give it this velocity that I just asked for, or just calculated. So there we go. So now we're spawning this ball here. And so I'm going to come back here. The last bit I want to do is I'm going to go back to my ball prefab and remove that initial velocity I put on there for testing. So on my ball prefab, I'll set that back to 0, that initial linear velocity. I will save everything and get ready to press play. Fingers crossed. Let's see what we get here. So no ball to start with, it's counting down. And then it's going to spawn the ball. And then there we go. We have Pong. And it's hard to play with myself while talking. And then, yeah, there we go. And so the ball is going to keep spawning. And that's it. Cool. So that is our dots implementation of Pong. It seems maybe a little bit more complex, since this was a decently long video, though in reality it didn't take very long to make. And once you understand dots, it kind of just moves very smoothly and stuff like that. So it's a fairly simple game in actuality, but I wanted to make sure that I fully explained the various syntaxes and the things that you could do and maybe some of the gotchas and stuff like that. So there it is. This repo is available online. You can download this project and this code. The link will be in the description. So feel free to check that out. Feel free to follow up with any questions you might have. Otherwise, hopefully this has been a decent video and project for learning some of the new syntax. As always, reach out to me on Twitter. I'm at Mike Geig or wherever else, and just let me know what you create.